This video discusses sampling distributions. A sampling distribution can be defined as a statistic describing the distribution of a statistic calculated from all possible samples of the same sample size taken from a population. A parameter describes a characteristic of a population. A statistic describes a characteristic of a sample. Relevant variables for the sampling distributions of sample proportions include p, or the population or true proportion, p hat, the sample proportion, sigma, the population or true standard deviation of the sampling distribution, sigma sub p hat, the sample standard deviation of the sampling distribution, and n, the sample size. Relevant variables for the sampling distributions of sample means include mu, the population or true mean, x bar, the sample mean, sigma, the population or true standard deviation of the sampling distribution, sigma sub x bar, the sample standard deviation of the sampling distribution, and n, the sample size. The standard deviation for a sampling distribution of sample proportions, sigma sub p hat, is equal to square root p times 1 minus p over n. This is true as long as the 10% condition is satisfied, which means that the sample is less than 10% of the population. The mean, p, is equal to p hat. The following conditions must be satisfied for inference. The 10% condition, the sample must be random, and the large counts condition, where p times n and 1 minus p times n are both greater than 10, to ensure that the sampling distribution is approximately normal. If conditions for inference are satisfied, probabilities can be calculated using a normal distribution.
Okay, so for sampling distributions of sample means, the standard deviation, or sigma sub x bar, equals the population standard deviation divided by the root of the sample size, or sigma over square root of n. But first, before you calculate this, you have to make sure that the 10% condition is satisfied, so the sample is less than 10% of the population to make sure that it is independent. And the sample mean equals the population mean, so x bar equals mu. The conditions for inference are very similar from sample proportions to sample means, as you have the 10% condition and random sample, but also for normality of sample means, the central limit theorem has to be met, where the sample size has to be greater than or equal to 30. Finally, probabilities are generally calculated through using a t-distribution for sample means. Some common errors that students make for this section are forgetting to check the 10% condition before calculating standard deviation, so that just goes back to making sure that the sample is independent through comprising less than 10% of the entire population size. Also, do not confuse sample distributions with sampling distributions because they are different. And you have to make sure you're using the correct normality condition for testing before actually conducting these calculations. So for proportions, you're using the large counts condition, and for means, you're using the CLT. Also, you have to know which distribution to use when calculating probabilities, so there's the normal distribution and t-distribution. And for the calculator, when you are dealing with a normal distribution, you have to go through statistics, distributions, and normal CDF, where you're typing in your lower bound, upper bound, mean, and standard deviation. And for t-distributions, it's almost the same. You're just going to 5 t-CDF instead of 2 for normal CDF. Some questions that are very similar, well, one is just 2007, number 3. It uses the concepts and assesses your knowledge of it very well. And the answers are here. We wrote it out for you. You can just pause the video. Here's part A, part B, and I hope this was helpful, and enjoy.